Hey everyone and welcome. Today we're going to tackle a big one of the most fundamental data structures out there, the linked list. And trust me, by the end of this, you're not just going to know what it is, you'll see exactly how to build one yourself right from scratch. All right, let's get into it.
So let me start with a question to kind of get your brain spinning. You know how you usually think of a list, right? Like books on a shelf, all neatly lined up one after the other. But what if it didn't have to be like that? What if every piece of your data could just be anywhere it wanted in your computer's memory, but still be part of a perfectly ordered line?
And that exact idea, that's what leads us right into our first section. So what on earth is a linked list? Okay, here's the formal textbook definition. It's a linear data structure where elements are not stored in contiguous locations. The key phrase there is not stored in contiguous locations. So forget the bookshelf. Instead, I want you to picture a city full of houses. Each house holds a piece of data. But inside each house, there's also a little note with the address to the next house in the sequence. That address, that's the whole magic trick. That's the link.
This slide really shows it perfectly. Over on the left, you've got an array. It's like a solid brick wall. Everything's packed together, it's a fixed size, and it's kind of rigid. But on the right, that's our linked list. It's flexible, it's dynamic. The elements can be scattered all over the place, connected only by those little pointers. And the best part? It can grow or shrink whenever you need it to.
So, how do we actually build one of these flexible chains? Well, it all starts with one simple core component. Let's talk about the main building block of every single linked list, the node. Think of a node as a single train car. It's got two really important parts. First, you have the actual data it's holding. We're calling it value. That's the passenger, the cargo, the important stuff. The second part is the pointer, the thing that will connect this train car to the next one. We call that next. It's basically the coupler between the cars. That's it, data and a pointer. Okay, so now we have our individual train cars, our nodes. It's time for the fun part. Let's actually connect them and forge the chain. So we start out with three completely separate nodes. As you can see, they've each got their own little piece of data. But right now, they're not a list. They're just three unconnected train cars sitting on totally different tracks, completely independent. And here's where the magic starts. We take the next pointer of our very first node and we tell it, hey, you are now pointing to the second node. And boom, just like that, we've coupled our first two cars together. A chain is starting to form. And we just do it again. The second car's next pointer gets linked to the third. And now we have a complete sequence. But look closely at the very end. What about that last node? Where does it point? This part is absolutely crucial. Its next pointer points to null. Think of null as the big red stop sign. It tells our program, that's it, you've reached the end of the line. Our train is now fully assembled. So, we built a list. That's awesome. But its real power comes from how easy it is to change. So now, let's get practical. We're going to look at the three main ways you can add a brand new node to the chain we just built. The first method is called push. That's just a fancy way of saying add a new node to the very front. And this is super efficient. All you do is create your new node, you make its next pointer point to whatever used to be the first node, and then you just say, hey everyone, this new node is now the beginning of the list, the new head. That's it. Simple and incredibly fast. But what if you need to slot a new node somewhere in the middle? For that, we use insert after. Now listen up, because the order you do this in is critical. First, you have to connect your new node's next pointer to the node that comes after it in the chain. Only then do you change the previous node's pointer to point to your new one. If you do that out of order, you'll break the chain and lose the whole back half of your list. But if you do it right, you've just cleanly spliced a new car right into the middle of your train. And finally, we have append, which is just adding a new node to the very end. To pull this off, you have to start at the head, at the very beginning, and follow each and every next pointer, from car to car, until you find the one whose next pointer is null. That's your last car. Once you find it, you just change its next pointer from null to your shiny new node. And just like that, you've added a caboose to the train. All right, we have covered a ton of ground here. We went from just a weird question to forging a complete working data structure. So let's take a quick pause and really lock in the most important things you need to remember. So let's recap. What did you learn? 1. Linked lists store data in scattered pieces called nodes. 2. Every single node has two parts,
the data itself, the value, and a link to the next one, the next. 3. We always know where the list starts because of a special pointer called the head. 4. We know when it's over because the last node points to null. And 5. We've got 3 easy ways to add new nodes to this awesome, flexible chain.
So we'll end with this. You now have the blueprint. You know how to build your own linked list from scratch. But the really important question is, where would you actually use it? Think about your browser's back button, or a music playlist where you're always adding new songs. Any situation where you're constantly adding things, or where you have absolutely no idea how long the list is going to get, well, that's the real world, and that's where the linked list truly shines.